Hi, everyone. Grab your drinks, grab your food, have a seat. We're going to be talking about distributed agent messaging and gateways. I'm going to just introduce the panel first. My name is John Perello. I'm a principal engineer for Outshift. I'm working on the architecture and some of the evangelism for agency here for multi-agent systems. And I'm going to just first start to introduce everybody here on the panel. We've got a really cool panel here. First, we got Dwahal Patel. He's a principal generative AI architecture lead. He is principal AI architecture lead at AWS, helping enterprises design and scale generative AI systems. He has over 2 decades in cloud architecture, AI, ML, and enterprise experience in digital transformation as well. His work centers on agentic architecture, LLM optimization, and scalable AI infrastructure. So please welcome him. And then after that, we have Ayush Chopra. Ayush is an MIT researcher for the Nanda Index and REP protocols. He's doing his research along with Ramesh Raskar, focusing on multi-agent systems and distributed computation. He leads Project Iceberg, which builds coordination protocol and simulation architecture for human AI systems. And his AI Touch framework and over 25 patents have been helping to advance real-world coordination systems for governments and enterprises. So please welcome Ayush.
Well, thank you.
Okay. Next, we have Idit Levine, who is the founder and CEO of Solo.io. Idit is the founder of Solo.io, which is a company specializing in cloud-native networking, service mesh, and API management. Formerly, she was CTO of EMC's cloud management division, and she helped lead OpenStack and Cloud Foundry initiatives, and she's a recognized expert in service mesh and Istio, and she's a key contributor to open source, which is why we're all here, and industry standards that are shaping modern networking. So please welcome. And then we have Karthik Ramgopal. He's a distinguished engineer at LinkedIn. He's leading the product engineering team that builds all member and customer-facing systems with over 16 years of experience in software architecture and large-scale systems. He bridges the back-end and distributed systems and generative AI infrastructure. He's a hands-on leader, continues to contribute directly to code and design while guiding LinkedIn's technology strategy. So please welcome the panelists. Okay, got it. Okay, so we're going to be talking about distributed agents and messaging gateways. And when you're talking about distributed agent messaging, it kind of presupposes that we have more than one agent, that we have agents that will be messaging. So I'm going to kind of just lead it off with some questions. So the first one is, well, we're going to be messaging between agents. Do we even need multi-agent systems? Like, can we just, are the current frameworks that we have set up for this? And do we need to have multiple agents working on a problem? So we'll start from there, and we'll just go down this way first and have each one answer that, and then we'll get the conversation going.
Well, I think that we have to take a cautious approach. The cautious approach is like, you first evaluate the business problem, what use case you're solving for. Don't jump right into designing the multi-agentic systems in the first place. Understand the return of investment. And more essentially, when you understand the use case, when you understand the complexity of the problem the agents is supposed to be solving and transforming your business, depending on the complexity of the problem, figure out the skills needed to solve the problem, and then break this down and decompose the whole complex problem into different types of the problems, and then try to figure out if you really need multiple agents or you can achieve the same outcome using the one agent. Now, if you go with one agentic system, there's obviously some constraints like how far a single agent can reason and solve the breadth of the problem space of that business problem. Number two, it may easily convert into context bloat, right? And the context bloat can result into performance issues, not just performance issues, but also the hallucinations, which is extremely essential to solve the problem when we talk about agentic systems. So at that point of time, you take the decision whether you want to decompose that big, fat, monolithic, one single agent into multiple agents and use multiple agents, agentic systems or not. So yes, definitely we need, but be cautious. make sure that you are solving the right set of problems with the right technology, and take a cautious approach, as I would say.
So it sounds like you're saying, yes, you need these agentic
Yes.
systems, but start out with the larger problem and decompose it. What about like internally or things like that? Should people just jump in and start doing it on the production systems, or what's the approach they could?
Yeah, I think the crawl, walk, run strategy would help. Like, take up a very simple use case to start with, see if it works, see if it's giving you the business value, see if it's giving the return of investment, and then take slow and steady approach and build on the single agentic systems. Like, I would, at AWS, we are extremely like cautious about all this, like not going right and jumping into multiple agentic systems. We take a very cautious approach. First, we go with a single agent, then we go with a couple of tools, or like maybe tens of tools, or maybe tens or 20s of tools augmenting the single agent. And then we go slowly with the orchestrator design pattern for a single agent with other agents communicating with each other, and then go full-fledged with multi-agent swarm or DAG type of multi-agent system. So I would say crawl, walk, run. Okay.
So yeah, short answer is yes. And primarily because I think like multi-agent is like a design pattern which emerges naturally in a lot of problems. For a lot of problems where like things where there are like multiple competing incentives, multiple goals, siloed data, or like multiple time scales of work, different entities working like asynchronously, the multi-agent design pattern becomes very natural. And it's not new for LLMs. Like, we've been doing it for like many years, even before LLMs. And like across all problems, from like biosecurity, trying to get like contact tracing apps to coordinate with each other, or like trying to design fulfillment centers where like different parts of a warehouse are coordinating with each other, or like even like across a wide range of problems, this design pattern emerges very naturally. And the TLDR is like, when you need a multi-agent system, you'll know it, because there'll be enough moving parts which is bottom up. Till then, for like most central enterprise problems, where people are using sort of having multiple agents work together in an orchestrated workflow, there you may or may not. And like sort of following up from like one of the last talks, like the bitter lesson of like Richard Sutton tells us we don't need it for problems where like you're just using it as a stopgap for a single LLM, which is not good enough. But for a lot of problems, having a multi-agent design pattern will emerge very naturally. Like, especially as you go to internet scale problems, where you'll have like a lot of competing parts doing extremely different work, and they need to coordinate with each other.
Yeah, honestly, the people before me did a very good job to explain that. That's not that different, honestly, if it's a microservices or if it's agents, same thing, right? You're always starting, you don't want it to bring complexity that you don't need. Definitely on agent, because the context is the agent. So how bringing the context to a distributed application? It's not an easy thing, right? So if you don't want to, if you don't have to deal with this, just don't, right? So start with the basic. What we see in the market, honestly, 99% of the customers has a very simple use case. You want to make sure that they're getting an outcome really quickly, because as we all know, there's a lot of money spent on AI, very little production actually value to it. So I will argue, like start simple, understand what is the small use case that you're doing exactly. I'm sorry I'm repeating, but it just was a very good answer. So start building one agent, figure it out, do not distribute it unless you have to, and as you mentioned also as well, when the problem becoming so complex that the agent just cannot handle it because is getting confused when you're giving him a lot of tools, or right? Then that's when you need to split it up. But again, that's becoming it's exponentially more complex, right? So if you don't have to, just don't touch that. That's the only thing that I would.
So I'll say sometimes you don't even need an agent, not even a single agent, right? If your space is deterministic, all you need is a rules engine. So don't overuse agents. Just choose what kind of automation you want and go from there. I think I wanted to talk a bit about the other part, which is, hey, are the existing frameworks enough? Well, they're not enough. Because for these agents to truly communicate with each other, we need more sophisticated, messaging protocols. You may ask, why messaging? Why not just do RPC? Well, the reason is because you need a source of truth somewhere to record what these agents said for two reasons. First, systems are fallible, so you need replay, retry capabilities. And like secondly, a lot of the content here is contextual. You could be referring to something else which you already said, like, hey, book me a flight to San Francisco. And then you say, I changed my mind, I want to fly to Oakland. So the second does not make like sense unless you know the first. So unless you have a persistent source of truth record to know you're referring to the first, you really can't get it, which is why you
Is that
need
not
messaging.
networking, or is that just persistent?
You need persistence, which is why messaging works as opposed to just plain old RPC without storage, without history, without like timestamps, without attribution. But you need a protocol. It sounds very simple. You need this contextual integrity. You need security, privacy, compliance, scaling all of this, which is why you need a protocol to do all this atop like messaging.
Yeah, so it sounds like you're saying that with the messaging, it implies we also need context. So I just send you a text, that's a message, but what was the conversation and how are we going to track that? What's the threads, the documents, the things that are going to be discussed, right? Okay, cool. One of the things we were talking about before also is what are the things to think about when you move from a simple agent? So it seems like just about everybody's building simple agents right now, and then we're talking about things that are way out here where we're like, okay, tons of agents are going to come together and work on that. That's a future, and they usually call the people that are predicting the future the heretics or something, but like we're way over here. So what are some of the things that we should be thinking about as we move from simple agents just sending messages to multi-agentic systems on a scale that's even a global scale? So what are some of the things we should be thinking about?
Well, I think this is obvious. The answer that I'm going to give you is communication and collaboration protocols, right? How the agents will collaborate with each other. And I think we need to dive deeper into the term collaboration because there are different types of protocols irrespective of whether we built an agentic system or not, like gossiping protocol, consensus protocol, voting protocols, like async protocols, synchronous protocols, right? All of those communication patterns becomes extremely important now because these agents are non-deterministic. They're stochastic in nature. They can go rogue anytime. As he shared one of the examples for the booking examples, for example, the things changed so volatile. It's so volatile that it's very hard to track. What am I supposed to do? Or like, what I'm working against, what goal do I have, and what I'm working against that goal, right? If the goal is changing dynamically as the collaboration proceeds ahead, right, in the protocol, like communication and collaboration is extremely important for all of these agents to work in a cooperative manner. And it doesn't have to be cooperative all the time. Some protocols might be competitive in nature, like you are doing a pen testing, for example, security pen testing, and you need to basically have an attacker and a defender systems, and they are competing with each other. And somebody is building an agentic system to develop a penetration testing. At that point of time, the collaboration is totally different than the cooperative collaborating system. So I would emphasize on collaboration. Second thing I would emphasize is discoverability of the skills of the agents. An agent needs to discover another agent based on the skills the agent is expert in. And I think A2A protocol and MCP protocol to certain extent has solved, I would say certain extent has solved the discovery problem, but we are not there yet. We need a lot of innovation there as well in terms of the discoverability part. I'll let others answer.
That's interesting because that's the things we were talking about in the previous panel about directory and then identity. And so we're saying that like, all right, we're here talking about messaging, but then without a directory and discovery, we can't have the messaging.
Yeah.
Idit, why don't we go to you on the question then and say, what are the things that we should be thinking about, in your opinion, that while we do
Yeah,
this?
so I mean, I would say what we see, right? I mean, I don't know. I'm working with a lot of customers, so we see what we see. As I said, starting small, very important. The second thing, though, that we see is that there is a very interesting thing in the organization itself. So this is what we see from our customers. I was just going to kind of like pin you. Our teams, the customer that we usually working with is the platform engineering team, right? We are Kubernetes, every kind of like team. So what we see is that before that in the organization, people went to the direction of the AI team and building the agent. We also see that those people who got the majority of the money went and looked for a platform like, for instance, maybe LangChain or maybe even AWS, right? Something like that. And they basically tried to build their agent there. what we see is that it's not working. Like people are not coming to production. And the reason is because if you're looking at LangChain, I'm just picking on them, right? But I mean, it's just an example. Those guys are usually, they build a platform with its Python engineer. Their job in the organization was never to bring people to production. So now the question that I will ask, what do we need to do in order to bring people to production? And where is the gap? And the gap is the infrastructure, right? And I think that the big clouds solve that. I think agencies trying to solve that. We're trying to solve that. And I think that what we see there is that it's going back to the platform engineering team. And now the question is very simple. What piece you bringing them to bring that thing to production? And you will be surprised that the people that are getting it is the API team and the platform engineering team. And what they're trying to do is to take the protocol like MCP and basically create A registry, and B, get out somehow to protect, right? Because MCP is very, it wasn't built as an enterprise. So what we see is that this is a big problem right now in the organization, and that's the two things that we see that people constantly trying to solve right now.
Yeah, so it sounds like the same thing we learned about, like, while trying to form agency, is that if you want to do messaging, you can't just do messaging. You have to think about context, and you have to think about discovery, and it comes into all of these different things. So why don't we switch up? Go to
Yeah, so I'm going to talk about three things. The first is perhaps obvious. You need clear separation of responsibilities. What agent is doing what? Okay, what are its boundaries, etc., in any sort of multi-agent system. The second thing is context management and various forms of like memory. Okay, memory can be as simple as conversational memory. It can be episodic memory, procedural memory, short-term, long-term, pretty complex. And I know we talked a lot about, messaging in the context of an agent communicating with another agent. There is also the concept of agents ambiently listening to what other agents are doing over a sort of event stream and building up their own sort of like memories, right? The third thing, which doesn't get a lot of love, but which is very important, as important as infra, is evals. And evals become way more complicated in a multi-agent system as opposed to a single agent system. And evals also needs infra, different kind of infra, data infrastructure, playgrounds for doing reinforcement learning with human feedback. Like all these things need to be built at scale in order for this to actually function in a viable way.
Yeah, so there's a lot that has to be put in place before you can efficiently message and have a job to be done with the messaging. What's your take on this, Ayush?
Yes, I would say this is a question that's very close to me because most of my research that I do is very focused on building exactly protocols to let agents coordinate. So I'm very strong believer in that you need a very rigorous way for agents to coordinate with each other. And most of the protocols we see around today are very focused on message exchange and communication. And that's good for open-ended conversations or for most applications like information retrieval, discovery, where most of the data is sort of static and at rest. And most of what an agent is just doing is sort of orchestrating where to pick and what data to get in sequence. But for most real-world problems that are very dynamic, the coordination protocols sort of need to have more intelligence in them. So the intelligence doesn't just sit in the agent, but the intelligence is also in the protocol to figure out is the agent getting to goal, anticipating needs of other agents, and then making trade-offs to make sure tasks get done. So I feel that's going to be probably the most interesting problem to solve.
Yes, so actually on that note, right, English or any other human language is extremely extensible, expressive, but it's also very inefficient for communication. So one of the things we learned pretty early on is in all of our messaging protocols, you have to have a combination of structured as well as unstructured data to be able to express both. And this intelligence part is very important because you ideally want decentralized intelligence in order to enable, these real-world multi-agent systems. Part of it is in the protocol itself being intelligent, and the protocol enabling what I call as pluggable cognition for it to be truly plug and play. And which is why it's very important that a lot of this innovation ideally happens in open source or is at least an open standard of sorts so that everyone can truly, benefit and have an adaptive system built as opposed to everyone just building in silos.
Yeah, and it's interesting because just linking into the last session, we're saying in order to do this, we need decentralization. But then the whole talk before was in order to monitor this, we need centralization.
You need both, perhaps.
That's kind of, yeah. It's just interesting that both.
But yeah, I very strongly agree with this part that this is primarily there's one takeaway, just one of the reasons where things like LangChain are not enough because they're sort of solving a lagging problem. They're trying to orchestrate agents where their sort of magic is in the flexibility of agents and putting very controlled, centralized workflows on top of them, which makes them sound like microservices.
Well,
And like,
actually, no. I actually work pretty closely with the LangChain folks. I also sit on their customer advisory committee. They started off like that, but of late, they are expanding more into more open-ended stuff. If you look at some of their examples with the deep agents, etc., where they're building more open research stuff, I think a lot of it is just educational, right? LangChain alone is like not enough. It's just a orchestrator over LLMs with some convenient functionality for doing things. The infrastructure piece, which is being filled in by cloud providers, and the data infrastructure and the eval pieces are what, in my opinion, are truly missing to build this end-to-end story.
but like coming back to your point of like, if you really want like decentralized nodes where like even if like the protocol brings the intelligence or like the pluggable intelligence to like even like route requests at the right time, that sort of fundamentally breaks down the moment there is a central orchestrator, because for most internet scale problems, there isn't going to be one. So like they're probably good for like prescribed problems and workflows, but like how do you see it working in scenarios?
So actually, in this regard, one of the feature requests which we gave to the LangChain team, which they solved for us in a pretty interesting way, is to build a dynamic LangGraph graph, right? We use LangGraph pretty heavily with like dynamic nodes, so that orchestration itself can be fairly decentralized, and you just have a routing graph, and the routing graph routes to subgraphs, etc. So you incrementally build atop it. So I think there are ways to solve it.
But it's
not enough, though.
A, you hacking, and second of all, the question is that, as I said, like, I'm the one who's constantly saying, let's see where the market is right now, but let's see where the market is going to. And that's not what we're talking about, right? The LLM is getting better. We never need to build what there is right now. What we need to look at what's going to happen in 6 months in the LLM, and they're going to orchestrate that. So you will not need all those like state machines that they're building around to support. That's number one. And number two, even when we're talking about networking, I don't know if you guys see the new stuff that Anthropic is talking about, but everything that related to skills. That's damn interesting. And that will be very, very interesting, because we're talking about the networking all the time. That's not the way they're looking at this, right? They're actually looking at very local, let's bring the context to the agent. So I think that there is a lot of interesting stuff to talk about. And it's interesting, like as I said, there is where the market is, the customers, there's where we are, and then there is those guys who's flying to the sky.
And that's where,
and it's interesting to see.
So I just wanted to respond to the stuff coming into the model. I do think over a period of time, more and more stuff will come into the model. But I think, it's going to be expensive initially when it comes in. And
make sure that it will be cheap.
There's only so much you can do, right? Just given, the training costs and all these things, which you have to reap at some point in inference, right? And I think the second thing which is important is sometimes you do want determinism for some of these things. And again, this is a consequence of where the market is, what the customers want, which is why there may still be room for deterministic software doing some of these things, as opposed to letting the model delegate some of these things.
Yeah, and I think that's interesting, because we start talking about messaging, and then we're like, well, what's going to happen at the other end of the messages, and is it going to be deterministic, non-deterministic? So let's talk about all right, the agency, we're in the open source, we're trying to do the good work and come around and organize all this stuff. There's a lot of good work that came out of MCP. They did the noble effort, A2A, bringing the semantics in. Let's talk about it where we are now. Is it good? Like, are we done? Is MCP and A2A good enough for what we got, or are there things that are shortcomings? And you were anxious to answer, so just go for it. Go for it.
Yeah. So it's a good start, but we are not there yet. There are lots of things I would like to see personally enhanced in both the protocols, A2A and MCP. Number one, for A2A, I'd like to see more the discoverability part of enhanced. Like, obviously we have agent cards, but I would like to see a more sophisticated system that does the discovering of the agents based on the skills. So kind of an agent registry, and kind of if A2A can standardize the protocol, like, here is how customers are supposed to implement an agent registry. Awesome. Otherwise, we are just, at AWS, I work with lots of customers, at least 10 customers a day. And every customer I talk to, almost every customer, they talk about, can you give me an agent registry? And it's like, yes, we will build it for you. But hey, it would be awesome if A2A can take up a PFR or a product feature request to standardize how an agent registry should be built, what features should be embedded into the registry. Should a registry take up a concern for the fine-grained access control or not? Or should it be dedicated to the individual agents of what is allowed and what is not allowed? Number one. Number two, the security part of the multi-agentic system. We are not there yet for the A2A protocol. Like, I'd like to see more stronger a specification built into the protocols as far as like the security is concerned. Like, just saying that we will support OAuth 2.0 is not enough. We need to have a prescriptive guidance on if a sensitive workflow is triggered, what is the guarantee that a malicious agent doesn't misuse the sensitive data, or is it, if the agent is even allowed to execute the sensitive operation? The tokens, for example, issued by the OAuth 2.0 protocol, right? Like if an authorizer issues a token, the token could be a long-lived token which could be misused by the malicious agent, or even an agent is not malicious. It's possible that a token could be misused to execute some other operation. So we would like to see like a short-term token or ephemeral token embedded into the protocol. Number two, the overly broader scope that a user might inject into the token itself could be misused by the multi-agentic systems. An agent could very well use the same token, like we call it as God token, for example. Like all my customers, like, can I use a God token, like one big fat token that is applicable for all of my agentic system that I can feel free to pass over on multiple systems? Absolutely. I said, no, don't do that. Use act on behalf. Use the delegation model rather than impersonation model. And do I have a prescriptive guidance for that in the protocol? Absolutely not. And we need to do that. Like, so these are some of the two things that I would like to see embedded into the A2A protocol.
Yeah, so it sounds like a theme coming here where it's like when we're trying to do messaging, we're always falling back to like, we need security and we need identity and we need all of the things that we're trying to do here in the agency. So from your research perspective, what do you see on that?
Like I'm a scientist, so my job is to just like look forward and let them take care of like things to make it work. But like things that I see are like somewhat already on like a near-term horizon, but two things I'm really excited about is, first, I feel like the protocol should essentially support like more asynchronous computation. Once that starts to happen, like a lot of really interesting applications will start to play out, where like if you send me a message, before responding, I could like spin out like 4 different agents to do like arbit stuff, get the answer back, and when it comes back, send it back to you. So that kind of asynchronous computation is going to be really interesting, doing like state management and stuff like that for that. And some of the other things I feel is like having the ability to do like more formal verification and like guardrails on the agents will open up a lot of possibilities, especially to take it to like very domain-specific verticals. Because like outside computing, like at least like this kind of like organizations we've sort of collaborated on research with, they seem to focus, there's like very standardized understanding of protocols that already exists, which are like regulatory approved and like validated in so many different industries. And to be able to like use agents there, it'll be easier to lead with the protocol than to lead with the agent. We're trying to get like a lot of the traditional industries adopt AI. So I think 2 of these things.
Yeah. So why do we have protocol? We have protocol because this market is moving so quick and we need to kind of like set up. But how protocol are successful, right? Why protocol are successful? It's because they're being adopted, right? That's the only reason they're really successful. So let's be very honest. MCP is the only one right now that really heavily being adopted. That's something that everybody using. It's very, very important and everybody using it. I actually feel that this is a less good protocol than A2A, but it doesn't matter, right? Because no one using A2A. So we need to be very, very clear, in my opinion, about protocol doesn't have to be good. It needs to be adopted, and right now MCP is the only one that adopted. What should we do in both of them? So I think that A2A did a better job because they're basically going to the RESTful, right, kind of like approach, which is what we're using in networking for years and we like. And so I think that's a good direction. Though, as I said, I don't see a lot of people, unfortunately, using it. What I do feel is that in MCP, their use case starting wasn't honestly for the enterprise, right? It was 100% from I'm using Cloud on my desktop and I want to leverage some tools. So, but then it got adopted so heavily, that's what happened right now. They're making it better and better. So I think what they did right now in the last, it's coming in November, so just right now, I think they added and standardized on auth. That's a smart idea. I think that they're adding more and more stuff. So honestly, they're going to the right direction as a community, which I think that that's what we should watch. And we'll see, because I'm not sure. I do know that they have some inspiration to take over the A2A as well. So we'll see what will happen there. It's interesting, but as I said, that's my opinion.
So I think MCP started off as a tool calling protocol. And eventually, right now, they have ambitions to expand to agent-to-agent communication as well. A2A started off as agent-to-agent protocol. Subtly different things, right? Because of the communication paradigm differences. So at LinkedIn, I actually put this out in our engineering blog. We have proprietary protocols for all of this, for both tool calling and for agent-to-agent communication. We support MCP as a second-class citizen for tool calling. We haven't yet started supporting any standard for agent-to-agent communication because, hey, we have to support MCP because MCP is very popular, and there are instances where we don't control the clients, and the clients only talk MCP, so we have to support MCP. Great. Agent-to-agent, no such standard has emerged. We haven't yet started integrating with external agents, so we essentially get away with our proprietary protocols. What are these limitations? I'm going to take 4 examples, okay, 1 from the tool calling world, 3 from agent-to-agent world. MCP, you get a flat list of tools. Works great when you have 10 tools, 15 tools, 20 tools. If you put like thousands of tools, almost all our RPCs have a tool abstraction adopted right now. It just freaks out. So we have this abstraction to do semantic filtering on the server side when you retrieve tools. How have we solved this in MCP? We have to hack together virtual MCP servers, no other way, right? Domain separated.
You should use Agent Gateway. Agent Gateway actually is doing it in the gateway in Rust. You should see it.
Okay, that's interesting. Then there is the agent-to-agent stuff, right? The first thing is human in the loop. A lot of the times you have to ask the human for approval. Now humans, you can't put a SLA on humans. A human can reply after 10 seconds, 5 minutes, 10 minutes, hours, days. So you have to freeze state and you have to restore when the human responds back. So you need some coordination, mechanism in the protocol to indicate that, hey, freeze state, restore, etc. A2A has something like, no, right? So that's problem number 1. Problem number 2 is this entire identity stuff and delegation stuff, which was talked about. No official spec for that. That's a big problem. Then there's also a third problem around sometimes I do not sort of want this mechanism of everybody raise your hand and respond, whoever can offer me this like service, right? I need more directed, targeted communication. I need context-specific, graceful degradation when, one agent is not available or is more expensive. And I need all these things encoded into the protocol, because when you do things at scale, these things start to matter from a quality and cost perspective, which is why we are still doing proprietary stuff and hoping for stuff like agency to catch up and, more importantly, become very popular before we can adopt it.
So that maybe a quick round. We were talking about, like, one of the things we're doing is doing this all in open source. I mean, do you guys see the benefit of doing this maybe in open source first and then the standards second? Yeah. I think we talked about this before, and we said that was like pretty important to do it in the open source, not go standards. It's just too slow.
Yeah, it's too slow. The space is moving really fast, and unless the standards bodies evolve, this is not the right fit.
One of the things we were talking about before was the messaging patterns, right? So you can have one agent talking to another agent by a request response that looks like an HTTP request. And then there are other ways of doing things like a publish and subscribe, and there's NATs and there's TIBCO. And then we're talking about more future ones where all the agents are coming together and they're just communicating. And then we just saw today during PyTorch that MCP was showing like, oh, okay, we can do MCP and then use that for agent-to-agent communication over Slack. Well, it's kind of fitting a tool call into agent communication. Yeah, I see everybody wincing on that. So are there different communication patterns that will come about because of that, or do we have enough patterns in here? Is the traditional patterns of maybe pub/sub or request response, is that enough, or do we see different messaging patterns coming up because we're going to have an agentic world? And you seem ready to go.
So we are already using one other pattern, which is offline bulk loads, which is typically used for sleep time compute. Say you want to do preference extraction or things like that. None of these patterns seem to work. And even for synchronous as well as for like pub/sub, just taking an existing system, for example, if you stick some sort of message queue, or you stick Kafka or something, it's not going to work. You need a layer above it, because you're dealing with structured and unstructured data. You need policy, you need compliance. you need privacy, visibility checks, you need ownership checks, and you need security. Like all these things need to be layered. So you have to build atop these lower level primitives when you're doing agent to agent communication at scale.
Yes, I would say it's less about what kind of sort of messaging pattern emerges. I feel like the more interesting things will emerge in the kind of multiplexed communication that will happen. That a lot of communication here is even with if it's Slack, I'm sending you a message because I mean to send you a message, but we'll start to see a lot of active and passive communication. It's I don't know, when a bunch of ants move around the world, they actively interact with some neighborhood ants, but they have this sort of passive process of leaving around pheromones. Now, pheromones help sort of ants coordinate with ants they will never directly cross paths with. So I feel a lot of these multiplexed communication patterns will emerge because agents don't have the same cognitive limits as humans and can work at multiple time scales at once. I mean, you can put SLAs on them, so which means that's what I'm a lot excited about, that I feel agents won't just do message-only communication, but there'll be these sort of first order, second order approximations of communications, sending more mathematical thinking of gradients, Hessians, these kind of communication patterns that will emerge.
One other thing, at Amazon, we have lots of long-running batch use cases. I think you were talking about that. We at Amazon, we have long-running, deep research type of tasks, like molecular study and understanding the drug interactions, for example. There are other different types of deep research that we internally are developing at Amazon, and that requires a long-running tool calls or long-running agent calls. And we don't have a definitive, in the protocol itself, we don't have a definitive pattern in terms of how the long-running agent should behave, or how should it be implemented for optimizing the throughput, for example.
We have something.
Okay, yeah. So one of the MCP protocol, in the MCP protocol, we do have a tools notification as part of the protocol, but that clearly is not enough for us, because whenever a task is submitted or whenever a tool call is submitted and the tool takes 2 hours, 3 hours, or whatever, whatever the time it takes, and then we need to be able to retrieve the status of the tool call. I don't know if the MCP server has given up on the tool and has given up on the connection. And so all of that state management, task management, tool call, result management is still lacking in MCP protocol. I would like to see that more mature in terms of the communication pattern for the long-running tool calls or long-running agents.
I think one huge aspect there is also resilience, status updates, monitoring, and also resilience, which is retries, which is where checkpointing, state management, restoration really starts to matter. And all this has to be part of the protocol, because if everybody starts building this in different ways, you have a huge operability and explainability problem at scale.
I think that Google right now is actually did a pull request, or they're at least trying to make MCP a little bit more restful. So you can see that they're trying to take it exactly that problem, because one of the problems that Google has is that they have all those services on Google, and they want to MCP each of them, and it's just never going to scale with the stateful protocol. So they are trying to do that. It's not going to help with the multiplexer, but it is going to help at least.
So I don't understand how it will work with MCP, because fundamentally HTTP is not meant for holding on to a long-lived connection forever in the orders of time we are talking about here, right? Few minutes, sure, few hours, sure. Sometimes if it takes several hours or few days, you are going to see connection loss, jitter, problems, etc. So is it really the right protocol? And also, is it the right use of resources at scale to be holding so many connections which are basically doing nothing and waiting for something to finish?
Yeah, you need a request response, but not at the time scale that
Exactly.
it's going. So you might need some new protocols. That's why we have the working group there. We've got a little bit of chunk of time here, about 7 minutes left. There's a couple of things we want to get to, and then maybe some questions. Let's do a fast one here. One thing that we got from a lot of people that were attending, that were they were saying, well, if you just take your LLMs and put them in a microservice and then use our existing processing, shouldn't it all just work? Do we have enough around that can go? And how would you answer that one?
Oh my
Kinda
God.
go
No.
No, okay. We get that response a lot. Yeah, it's microservices.
Microservices, they have definitive deterministic business logic embedded in them. LLMs are clearly non-deterministic, stochastic. They are rogue. Like, I am going to believe that they are going to do things that they are not supposed to do, and then I have to build the whole system based on this assumption. And so there are lots of different types of security concerns. Again, I go back to the security and making sure that it is secure and it is acting in terms of what it should be doing and aligned to the goal. So microservices, yes, it's a paradigm of building a modular APIs and modular software. Yes, some of the things definitely like composability, single capability, loose coupling, all of those things will definitely apply to building multi-agent systems. However, there are differences. The differences are the way how microservices today authorize themselves, right? There's a God token, or there's a service-to-service token, or there's a machine-to-machine grant types that just clearly evolved because of that. That's not going to work for multi-agentic systems. We need act on behalf. We need identity propagation. We need things like fundamentally how we as an architect would come up with what is the right size of an agent. What is an agent versus what is a tool, versus what is an MCP server. All of that requires a fundamental shift in understanding how we design an agent in the first place. An agent is essentially should be goal-oriented versus a microservice is a resource-oriented. A microservices is governed by a domain-driven design today, which is very well set space, and there's a very well set principles for that. But we don't have a definitive prescriptive design principles for how do you design an agent-driven architecture. I don't know, I've just coined that term. But we need to design possibly these agents based on skills, based on based on the goals that they are assigned to. Versus the microservices are just simple resource-oriented architecture APIs. Yeah. So these are some of the things that I would think that there are similarities, but there are fairly different things that we have to consider when we are designing the agent-oriented systems or agentic systems.
And Idit, let's get your report.
Yeah. I mean, I'm kind of agree. Yeah, it's kind of agree. So, I do think that it's a good, like we have a good foundation. Microservices are good. We're running scales in every organization. The biggest companies in the world running it in scale that is crazy. Okay, so now the question is what is missing? And microservices are stateless, right? That's all the point, right? I mean, when we're building it, we don't care about state. Agents are not stateless. Potentially, there's memory. There's short-time memory, long-time memory. There's the identity problem, right? You don't want them that if I will have, they don't want them to act on my behalf and delete the cluster if I have that permission. You want to give a very small, specific scope to this, right? So we're calling it on behalf, right? That's true also, by the way, for if you're looking at microservice and as a MCP, right? I mean, there's big problem there with identity and token that we need to swap and so on. But in the nutshell, what I'm trying to say, it's a good foundation because, guys, like we're running in every other company, like huge companies, microservices with service mesh, not BAS, by the way, but service mesh, and it's working fantastically. I think we can deck it. We should have some, layer on top of it because, as you said, the people who wanted to run it maybe care about agent and, maybe tools and maybe policy. They don't care about the rest, so we need to abstract that. But in the nutshells, we can, if a container is going down, we can bring it back and bring the right memory to it. So I think there is a lot of stuff that we're doing, and honestly, it's working really, really well. So, I mean, I can show you. It's pretty cool. But it should, in my opinion, there is an amazing foundation that we know that's working really, really well. We should leverage the hell out of it. That's true also for the protocol. We shouldn't invent new protocol. We need to extend the one that exists and so on. So.
And speaking of other protocols, Ayush, let's give you a chance to talk about the ripple effect protocol, RP, that you're working on. Does that fit into everything that we're talking about here as well?
Oh yeah, I mean, so that's like a new project, like Cisco and like MIT have been doing together with like similar goal to like put a lot of these ideas together and make sure we can build protocols that allow like large teams of agents to work together and coordinate under competing incentives, network topologies, and like having like many kinds of multiplexed communication patterns. So it's like, I mean, it's good to see like a lot of this conversation happen because it seems to like point towards the fact that like we've been sort of building tools that are
so some of the
headed in like a useful direction.
Yeah, some of the protocols that we've been using need need to be extended, need to be used in different ways, and we've got to start working on those. We've got at least about a minute and a half, 2 minutes left. Let's do the questions that I was going to ask. Let's just do like a rapid fire for everybody. What's something that's keeping you up at night? Like, oh boy, this is going to be a problem. And then what's something that you think is like, this is good, we got to keep doing it. So what's keeping you up at night? What's helping you sleep at night? And let's keep it a quick one to go down, and we'll try to get some questions.
You know my answer, the security is keeping
Security, we know that. It's like, without the security, we're not doing any of these messages. Like, absolutely. So security's keeping, what's things that you think are going well?
I think the good part is the protocol. Like we are evolving at a faster rate, and I think we should keep on doing that. Like keep on evolving those A2A and MCP protocol, and keep on doing this and bring it on, like the innovation, that the pace of innovation that is going on. I love the velocity. I love the pace of innovation there. So that's good. Security is not something that
Secure and speed.
concern.
Okay, what do you got, Ayush?
So what I'm excited is like, I'm very excited that the world finally cares about multi-agent systems. I spent most of my PhD with no one caring, and very glad to see like protocols are becoming a first-class
Well,
citizen.
and AI too. Like, it's
And, like,
we're finally doing
also.
it, right?
But like what I feel like keeps me up at night, I'm an academic, so like I see like people do good stuff when there are like good leaderboards. So we're able to build great agents because like we've got like very good agents, sort of leaderboards to measure how good an agent is. But I feel what we really need is like leaderboards of like how good a protocol is, because like right now like protocols are being treated as like very like static pieces of software through like orchestration or layers. But if like for stuff to really work and like intelligence to move into protocols, we need to have like good leaderboards for like protocols to figure out like how, because like even like the economic context. So like OpenAI, Mercer are trying to build a lot of these like benchmarks of like agents doing like isolated economically valuable work. So since a lot of the economic work is actually teamwork, it'll be very interesting to have like leaderboards of like, can like groups of agents come together and solve like economically valuable tasks under like specific constraints and scenarios. So that's something I'm hoping happens soon.
Okay.
Yeah, so I mean, the only thing that I hope that we as a community will do, all of us, is keep it simple, honestly. Like, I feel that we're overcomplicated, inventing new stuff, and it's fun. Like, I'm an engineer, I like doing this. But honestly, like, keep it simple. I think this is the most important thing, you know, as you say, crawl, walk, run. Really, really important statement. Security is scary, though. And to me, what is more scary is people are so excited about it, and to the point that when they're building their infrastructure, sometimes they're just doing the basic stuff to get it run. And then there is, it's called a beta request. You will need to rebuild everything, like, I mean, because there is a lot of hacks and a lot of stuff. So we need to find the balance between keep them something that is simple enough but solid to, you know, let them go by themselves and do crazy stuff.
For me, of course, apart from security, I got to give a different answer, right? Keeping it real. GPU capacity, availability of compute is a huge thing, because even if you have the best of ideas at scale, if you don't get capacity, it's hard, right? And capacity is hard. What's having me excited is few years ago, this was all about doing flashy demos. But at least from like last year or so, at least we at LinkedIn have started seeing these products actually making money out there. So it's exciting to see this technology getting monetized, like especially because it's so expensive in the first place.
All right, so we have the break coming up, but maybe can we do a couple questions from the audience, or are we gonna go? Yeah. So if people have questions, yeah.
First of all, thank you guys for sharing. You guys mentioned protocols so many times during this presentation. I do have a question. In the open source community, there are many talents are developing great protocols. So how to draw attention from the industry and getting adopted, like those open source protocols?
I think that if it's a really good protocol, organically adoption will happen. It's just like any of the frameworks, right? Because see, even in the industry, people want to do things with as less resources as possible in as short a time as possible. So nobody wants to reinvent the wheel. So people are always on the lookout for new things, right? For example, something which I do and ask members of my team to do every week is spend some time reading like papers and also looking at the code associated with these papers to try and understand what's going on, right? Or just do a scan of open source repos, look at Reddit, look at Hacker News, look at everything. Like if we can use something, why build it? It'll happen. So far, the problem I'm seeing in open source actually is the opposite one, that there is a lot of hype, right? Saying, oh my God, this is awesome. This is a great protocol. It works for a toy project. You apply it at scale, it breaks apart.
So that's where I'm going to do shameless plug for what we're doing. So we love protocols. So like one of the things we're trying to do with agency is take the protocols, try them out at scale. We got our coffee agency in there, and we're going to actually try it. The best way to find out if it works is to do it. So join up and do it. That's me shamelessly plugging the work that we're doing here. But, you know, hey,
I
I'm
think
the
that
moderator.
protocol sometimes is driving by big companies, right? I mean, the Google of the world and this. I think interestingly enough, if you're looking at MCP, that's not the case. I mean, the people who adopted it came from down, and then eventually OpenAI, and then Microsoft and Google, which is very interesting. I think this is a different market, which I love it and excited about it. We, the startup, is actually a big kind of like push. We can influence, we can actually make the decision. So I'm excited about it. I mean, and in the nutshell, which one you should choose, look at the market. I mean, it's very clear, like MCP right now is like, right? I mean, it's really, really clear to see that this is the winning one. You know, the other, we should see, well, you know, what will happen, but this one is a clear winner for sure.
Hi, so we are deploying multi-agentic flows for the real, enterprises right now. And we deploy agents at multiple locations and so on. So one of the challenges we face is latency in the communication, and secondly, this amount of data that goes between. So learning from the networking, like we went from the node to node to switching to routing to SDN. How do you see this journey, and do we need midpoints in this communication, agentic communication?
I think you are the only person who care about latency in AI. For some reason, people doesn't care about that because they're saying the LLM is slow, so why should we care? Which is a huge mistake, because the LLM will get better, and then you will only care about latency. But for us, I can tell you that, we are a networking company, and and we're running, big infrastructure, and they're seriously putting us in the contract. It can go more than millisecond, blah, blah, blah. And then AI come, and everybody is okay with latency. So.
So even for agent to agent, I think that there are some scenarios where people expect low latency responses. Now, I'm not a networking expert, so I'm going to tell you stuff we do in the software stack. Firstly, for these extremely latency sensitive scenarios, it's very important to choose the right model. So sometimes the foundational, model is very expensive, right? The commercial one. So you take an open source model, you like fine tune it. You can do a lot of model optimizations in order to get the size down. You can do infrastructure optimizations on the serving side to get the latency down further. You can also do data infrastructure optimizations with intelligent caching and context management to get the latency down further. So just reduce the cognitive complexity down to a point where it's so small. For example, like routing. For routing, we originally used to use GPT 4.0, 4.1. Right now, we do routing with small SLMs, like distilled SLMs, which are very small, which can do routing in the order of like milliseconds, as opposed to spending a second or 500 milliseconds. Does it require work? Yes. It's all about, hey, do the training costs and time, are they more than made up by the inference savings? And same thing for infrastructure, right? Speculative decoding, KV caching, distributed KV caching to a large extent. All these things help a lot with latency.
Yeah, from the networking world, like that's one of the works that we're doing in Slim in the group is saying that like, well, yeah, you've got these high cognitive loads, but think about if you're doing a video conference or something. If we're speaking in it and the latency goes down, I missed it. And now I'm doing computation and I'm behind. So that's where it's not just the latency in the messaging, but it's the latency amongst the conversation that we're having. I think we have time for one more question, then we're going to have to break. So if there's one more, okay.
Thank you. You mentioned you took a page from microservices. I was wondering, there's other things that we have invented, like real-time bidding and programmatic ads in a marketplace. Is there a page that we could take from that in the A2A in the future?
I think the RTB stuff is pretty interesting when it comes to the scenarios I talked about where like multiple agents can do the same thing. Again, this is far out into the future. I don't think we are there right now. And if you have to trade off between them from a cost, capability, availability, latency perspective, protocols like this can help. Whenever there is some sort of competition involved and you have to make a cost determination. The other area where I think protocols like RTB can help is efficient communication of the state of the market, right? The order book sort of, right? Because that is also going to be very important as you start broadcasting about health and availability and all these things at scale.
Awesome. Well, thank you everyone on the panel. Big round of applause for the panel. Thank you all for your questions. And we have our break coming up. Thanks so much, everybody.
Thank you.